Right. So in this video, we will discuss some properties of conjugates and properties of modulus. These are very important when we are doing problems, especially past paper questions, because we don't need to go too much of arithmetics. If you know these results, you can just get to the answer within few seconds. So it's important to know this. So conjugate of an addition is equal to addition of the two conjugates, right? Addition of the two conjugates. You should be able to prove this. So try the proof by yourself before you come to the class. I give you a hint. Take z equals x plus yi and z2 equals a plus bi. Set them equal to these two complex numbers. Then try to prove it. Left hand side, right hand side. Okay. Then conjugate of z1 minus z2 equals conjugate of z1 minus conjugate of z2. Then conjugate of a product is equal to the product of the conjugates. Conjugate of a quotient is equal to quotient of each conjugate. Here you should know that z2 is not equal to 1. If z2 is, it's not equal to 0. If this is equal to 0, this would really blow up, right? So these are some of the properties. So based on this, we'll do more questions, and before that, we'll do proof of these properties. So you try this on your own, right? Try this on your own before you join the class. Okay. Next, we'll look into some important properties of modulus. Right. So properties of modulus. Modulus of product is equal to product of the modulus. Right. Then modulus of a quotient. Modulus of a quotient is equal to quotient of the two modulus. Then this is very important. We use this property when it comes to division of complex numbers. Product of a complex number by its conjugate. It has to be its own conjugate, otherwise this won't work. That is equal to modulus square, right? Square of the modulus of the complex number. It's not the modulus, it's modulus square. Then modulus square of the addition of two complex numbers is equal to modulus square of one complex number, modulus square of the second complex number, plus 2 times real part of this product, real part of this product. So you should be able to prove these results as well. Try this before you join the class. Now let me show you why this is important. Suppose now when it comes to division, for example, suppose you get 3 plus 4i divided by 8 plus 8 minus 6i. They ask you to take the modulus. Now what I am going to do, if you didn't know this property, what you will do is that you will divide this. So division is not that easy, right? You will divide it. What do you do? You multiply both top and bottom by this conjugate. Then you multiply the complex numbers in the numerator, simplify it. Then you divide this whole thing out and separate out. After that, you take the square root of the sum of the squares of the components. It's a long way around, right? But from this property, we know that this is equal to modulus of 3 plus 4i divided by modulus of 8 minus 6i. What is the modulus of this one? This is just 5. This is 10. Answer is up. Right? You can see how simple this is. Right? So just learn it and feel the difference. Enjoy doing this mathematics. This is not that complicated, but when it comes to past paper questions, you should have a certain upper hand onto it. So we'll do more examples during the classroom, hard examples, and somewhat similar to what you can expect in the exam. So That those things would be more of symbolic types, not addition, subtraction, and all. This would be more symbolic types, proofs, and all. And yes, so if you have any questions with regard to these videos, please do ask me, send me a message at WhatsApp so we can discuss before we begin the talk, because during the class time I'm hoping to do more examples, not the theory part. You have to go through the theory part first, then join the class. Okay, thank you for watching.